Good day to you all. This is a tutorials on how to install Flowgorithm and a short practicals on how to use it. So first and foremost, in the description of this video, there is a guide there, and you should find the link to this download page. Unfortunately, it's not a secured site. It's an HTTP link. It's not HTTPS, so it's not secured. So if you access it, you would get this kind of warning. And so once you are on this page, you would download the software. So the full installer package is recommended, but if you want only the executable, you can also do that. So it is a Windows application, 64-bit, and so first you need to check whether your laptop or computer is running 64-bit or 32-bit Windows. So in order to check that, you simply type in about your PC. So you not finish typing, you should get a pop-up like this. It's in settings. So once you click it, or when you come here and you click on open, the next thing you are going to see is your Windows settings open, and then you have system and then about. So in the about section, you look for the parts that they've written device specification. Under device specification, you are going to find system type, and then you know what type of operating system you are running. So mine is a 64-bit operating system. So once you've determined that, you install the 64 or you download the 64-bit installer. If you check yours and it is 32-bit, you come to download the old version. But you can try the 64-bit and see if it will run, but it is 64-bit and this is 32-bit due to compatibility issues. So, but I don't think they have a Mac version, but I've seen Windows application run fine in Mac sometimes, but if I figure out a workaround, I'll do a follow-up video, but you can explore. So once you've downloaded the file, it's going to be a zip file. So once you've downloaded it, in your file explorer, you are going to see the Flowgorithm setup.zip. So in your file explorer, you right click, and then in this drop down, you click on extract all, and then a pop-up will come. You don't do anything. It is showing you the directory where it is going to extract it to. If you want to change it to a specific directory, you can browse and then change it here, but you don't change anything. It would extract it into the same directory. So you click on extract, and then you can see there is a copy of the zip file here, but without the zip. So this is the extracted folder. When you open it, you are going to see, let me make it big. You are going to see two files. So you are going to use the setup.exe. I've already installed it, but let me remove mine. So my hard disk is spinning up, so let me wait for it to finish. Okay, so let me remove mine so that you go through the process once again. So now when you are here, after you've extracted, when you open the extracted folder, you see these two files. You click on the setup.exe, and then you read, and then you click on next. Over here, it is asking you which directory you want to install the program. And so if you want it to go to the usual program files directory, you just leave it as it is, and then install Flowgorithm for yourself or for anyone who uses this computer. I would advise, even though you are installing it for yourself, you don't choose the just for me or just me. You choose the everyone. Sometimes if you don't have administrator privileges for your laptop or computer, if you choose just me, sometimes some applications might be restricted. So please leave it at the everyone. For me, I prefer to store my programs in a unique directory, so I'll do that. So after I've chosen my directory, for you, if you like the default directory, you just click next, and then you click next again, and then you read the terms and conditions, you agree, then you click next. I doubt you read it, but it is there, so it's up to you. Then if this pop-up comes, you click yes, and then the application is installed successfully. So now let's launch the application. So let me minimize this so you can see the Flowgorithm application. So this is how the icon looks like. If for some reason you don't get it on your desktop, you can come here and then you type in Flowgorithm, and when the app shows up, you just open it. So if you open it and then you see main and end, it means you've installed it successfully and it's working fine. So at this point, you have done a successful installation. I'll try my best to respond to comments under this video. So if you have any questions, if you have any challenge, you can drop a comment and I'll do well to respond to them. So let me increase the font. So this is the Flowgorithm application. So in the lecture for this for Flowchart, the lecturer developed an application or a Flowchart algorithm similar to this. It's exactly the same. So this is a even and odd number flowchart. So we would try and recreate something like this. It will not be 100% match, but we'll try and recreate something like this. So this is we are now at the practical section of the video. So we'll be creating something similar to this. So this flowchart is simply a flowchart of an application that when a user inputs a number, it would be able to determine whether it's an even number or an odd number. So we try and do that here. Notice in standard flowcharts, usually the terminators are start and then end. But Flowgorithm is kind of like a program which you write using flowchart. So that's why we have the main function here, because after we create the flowchart, we can actually run it. In standard flowcharts, when you use these drawing tools, you don't really get the ability to run the flowchart. It's just for the drawing, the illustration. But Flowgorithm allows you to run it. So that's why you have the main here. So you cannot change the main and then the end. What you can do is add your shapes and then illustration of your program here. So the first thing you do is click on this arrow, you can see when I hover over it, it's highlighting. So when you click on it, this pop-up comes and it has the shapes that you may need to use. So let's create an identical flowchart as was given to us in lectures. So the first thing is input. So I click on input. You can see it's in there. And then under input, we have the if statement where the decision happens. And then on each side of the decision making, there is an output. So if it's false, it would see something. So we put an output there. If it's true, it would see something. So we put another output there. So this is a skeleton of the even and odd using the if statement when an input is passed. But remember, it is an application, so you need to start putting in variables and then actual logic. And in flowcharts, you usually put logics in these things. But the places where there will be output, you write your output statement as well. So we'll be doing exactly the same here. So in normal programming, you would have to declare variables in order to store values that are inputted into your code. So up here, remember we declare variables before we do anything else if we'll be receiving inputs. So up here where the main and then the input is, between that we click on that arrow, and then under variables in the pop-up you can see we have declare, we have assign. So we will be doing declare because we want to declare a variable. So now we've added this. You can see all what we added are grayed out. They are grayed out because there are no values or syntax in them. So if you try and run it, it's not going to work. So the first thing you can see is I've even highlighted the declare because nothing is there. The first thing is you double click on the declare. You can read this brief manual here and it tells you variable name. So I choose X to be the variable name. And what is the variable type? What type of variable are we, what type of data are we expecting to store in the variable? It's an integer because we are checking numbers. And so we choose the type integer. If it's something else, a string, a boolean, an array, you choose and then you set size and all that. But in this scenario, we are going to work with integers. So our variable, we choose the type integer and then we click on OK. So you can see integer X. And in the input section, you double click, you read, and then you understand and then you do what is necessary. But in this window, it's asking you what variable name should, or what variable should the input go into. So for example, if you receive an input from the user, where should you store it in your program? And we've already declared a variable to store an input called X. So we type the same name and then we hit OK. So anytime the user gives us an input, the input would store that variable, will store that integer or value in the variable X. And now we come to the decision point, the logic point. So the if statement, you double click, and then when this window appears, you write the logic. So what we are trying to achieve what we are trying to achieve is determine whether a number is odd or even. And we know even numbers are divisible by 2 and odd numbers aren't divisible by 2. And so how can we write it logically, mathematically, like code-like, that we can put in here? So for example, in simpler terms, we can just write, let's say the number is x, and we want to know whether it's divisible by 2. So we divide it by 2. If the answer is a whole number, let's say the whole number is y, and it has no remainder, let's say the remainder is r, then it is divisible by 2. So an example would be if x is, let's say, 3 and is divided by 2, our answer would be 1 remainder 1. So we are saying x, the integer or the input we are expecting. So if the user enter an input of x of 3 and we try to divide it by 2, and then we are getting 1 remainder 1, because we are saying y is the whole number, the number of times it's divisible by, and then r is the remainder. So when we have this kind of answer, we can say 3 is an odd number because there is a remainder. So if we pass another input like 4 divided by 2, the answer was going to be 2 is divisible by 2 times, remainder 0. So it doesn't matter how many times or how big the value becomes, as long as it is a whole number and then no remainder, then it is divisible by 2. So the answer is going to be 30 remainder 0. Let's choose a big number. 77. It's going to be 38 remainder 1. So we know when it is odd, it always has remainder 1. And when it is even, it always has a remainder of 0. So this alone tells us that there are only 2 outcomes when it comes to the remainder, whether either it is 1 or it is 0. So how can we write this in code for the logic or decision part of our flowchart? So we can say x. So if you are writing something, let's say C programming or C++, we know a special operator in C or C++ and most programming language is capable of checking whether a number has a remainder. without outputting the answer itself. And it is this symbol, the percentage sign. It is called modulus, if I'm pronouncing it correctly. So if you are checking a modulus of a value, it only outputs the remainder. There are cases where to output the whole number, the number of times it's divisible by, then the remainder. So we enter the variable x, then our modulo sign, since we only want to focus on the remainders. So we use the modulo operator and then 2, because we just want to determine whether it's even or not. So 2 is the number we use to determine that. Then equal to 0. So why equal to 0? So equal to 0 is a comparison. So if you just do 1 equal to, like you just type in 1 equal to sign, it becomes illogical. You are equating something that's going to give you a value to 0. So what should it do? But if you do 2 equal signs, it becomes a comparison. And so what we've written here is, let me type it here so it's much more bigger. So x, let me give some space, modulo 2 equal to 0. So this is what we input here. So we are saying the if statement should compare the answer of this, the input x modulo 2, which it will output a remainder, whether 0 or 1. It should compare it to 0. So we have already agreed or understood that if something is divisible by 2, always the remainder is 0. So that's why we chose 0 as a comparison value. So when a number comes here, after we've passed it in the input and stored in the variable, it becomes that number. So it becomes the x. So that number becomes, or integer becomes the x. So after that integer comes, the modulo 2 sign would check to see if there is a remainder. And if the remainder is 1, then it is not the same as 0. So the comparison doesn't hold. If this part runs, or if this operation executes and the result is 0, and then it compares and is the same, then it means it's true. So that is the logic for the if statement. So let me hide this, then press OK. So we have it here. So we are saying if we receive an integer and the modulo 2 of that integer is the same as 0, then it is true. So to take the true part, and then we'll output what is on the true part. If we take the integer modulo 2 and the remainder is 1, it means it's not the same as 0. So to take the false part and then output the statement or strings we want to pass or message we want to give to the user or onto the console. So now we've gotten the logic part down. So now our output. So double click again and then you type in your output. Again, remember this isn't just like normal flowchart. So you don't simply type as it is. So for example, if it's false, it's odd. And you can see new line has already been ticked here. So for some reason, if it's not ticked, I advise you take it so that your output would look nice, so that everything doesn't become or appear on the same line. So you take it. So once you enter your output message or statement, see what happens when you press OK. it says syntax error. You read the error and then you correct it. And then you can see it's red. But what it is trying to tell you is that usually when you're writing code and you want to print something out, when you're using the printf or any function that prints onto console, usually the string is in quotation marks. So again, when you're using Flowgorithm, you assume you are coding. So some of the syntaxes, you have to respect it. So when you put it in quotation mark and you press OK, you can see it comes here. So the output you are going to print out is odd. If it's true, what should be the output? So remember to bring your quotation mark is even. And then we have the output. So now we've been able to fill all the shapes. So the next thing is to run it. But before then, I want to talk a little bit more about the shapes. So the shapes are unique. You can't use them interchangeably when it comes to flowchart. So the first one is the main, usually the start. It's an oval shape. So if you look at the shape, the start and then the end, the terminator is an oval shape. So this shape is what you use when you are drawing a flowchart and you want to put in start or end. And then this is the declare shape. You rarely use this because in flowchart we typically don't add too much code. It's a sketch, so typically we'll go straight to input because we are not going to run a regular flowchart. But since this is Flowgorithm and it's a runnable flowchart, you write it as if you are writing code. So this shape here, it's a rectangle with lines at the left side and then the top side. So that's for the declaration. And then this parabola shape is for input and then output. So anytime you need to use input and output in your flowchart, this is the shape you choose or you draw. And when it comes to decision, we use the diamond shape. And the diamond shape is very practical. As you can see, it has 4 corners pointing perfectly up, down, left, right. So you can see it receives everything. It receives everything from the top, and then the left and right is branches. In some flowcharts, there could be another arrow going straight to the end, depending on the type of condition. So this is a two condition logic or if statement. There are 3 condition logic statements. So with there are 3 logic condition statements, you can use this middle part and then straight to the end. The end could be like if it's not a number, let's say if the person doesn't pass a number, you can just break out from the statements, whether true or false, and then go straight to the end and possibly pass out an output saying enter a value or something. So, but here it's a program. You don't control the arrows. You can add things at where the arrows are, but you can't move the arrows to points which you want. So over here, we only have 2 arrows coming off this decision diagram or if statement diagram or shape. Then we have the output is the same as the input parabola. And then this is the junction where everything comes together and then it goes to the end, which is an oval shape. And then these are the arrows you use to connect everything. So you notice that arrows in here aren't crossing anything. They are all following a specific path. So if you should have a program that branch somewhere here, You can't have a branch and then come and pass through here, here, and then go to end. You can branch out, come all the way here, down here, and then to the end. That is if you are doing a flowchart outside this program. But you can create complex flowcharts that you have something similar, but this is a simple one. And so now we try and run, and then a console pops up. So in the console, you can pause, you can stop, and then you can run. So there is a note here. Please enter a value of type integer for x. So we'll start with 7. And then when we click enter or we press this, it runs and then it says it's odd. Then we run again. You choose 8. It's even. Can try a bigger value. It's even. It's odd. So the program is, or the flowchart is working. So this is the benefit or big advantage when you're using Flowgorithm. You can literally run your flowchart. So there are other features we would explore after this. And so up here, the ribbon here, most of the things are self-explanatory. This is the file section if you want to open a new file or something, but I haven't saved it here, so we can't use that feature. If you want to save, you click here and then you choose a file name and then you save. There is the file, there is the edit, there is a program, there is appearance, window, tools, help. Over here we have the play, the step, the pause, the stop, and then the run speed, ignore breakpoint, the main function. So if you want to add your own function, you can create them here. And then the function manager. If you have functions here, you can import functions. Then this is to self-explanatory. The auto layout, the layout window. We have the variable watch. So if we click on the variable watch, you remember this was the last variable we gave the program, and you can see where it is stored. So if you should have written a complex or you should have designed a complex flowchart and there are several variables in several stages, this can help you track them, because there are scenarios where when a variable is initialized or being used at certain position in a code, it doesn't refresh if the code is a loop, and then you run into errors. An example was the around the sun C program we wrote. The error we had was the position where the inner loop variable was declared. The inner loop variable stayed at 1 and couldn't reset after it runs. So after it runs, if it hits 5, it stays at 5 till the program finish executing the outer loop. But it was supposed to reset every time. So if you have this variable viewer, you'll be able to track all the variables at any given or after you run the code, so that you know what is happening at each point, and it can help you easily debug. There are a lot of features here you can explore as well. And then we have the console window. That's where the code was run. We have the turtle graphic window. I haven't had time to play around with this, so you can explore that later. And then there is a source code viewer. This is the ultimate feature. So if you click the source code viewer, initially I set mine to JavaScript, script, but when I installed it for the first time, it was on auto pseudocode. So you can see, after I've taken my time to draw or create this flowchart, I can easily come here with a click of a button. I can get a flowchart. You can see, very simple. You can get a flowchart. You can copy it to clipboard and paste it in a program or something, or you can save it into a file. And these are all the language you can convert your flowchart into. So for example, unfortunately, it doesn't have C, but there is C++, there's C#, there's Bash, there's almost all the popular programming language. There's Java, JavaScript, Python. So let's try C++, and you can see we have our C code. So you copy everything here, you paste it in a file, you compile and you run it. You should have the same behavior or function. Let's try Java. So you can see it's respecting all the syntax. Python, you can see, also respecting all the syntax. So this is very beautiful. This is the great feature. I've learned programming for a while and I've never come across this program. If I'd had this from the beginning, I would have loved programming the first time I tried it. So this source code viewer is the ultimate feature of this application, aside from being able to run a flowchart. So this is the end of the video. So let me save the file. So I'll call it test2. So maybe I'll create a OneDrive, drop the files, and then the setup in there. So if you want to download them and then install and then try and copy the file, the flowchart we just created. So running it one more time. So maybe I'll do a part 2 and then I'll create a complex program with this application. So that is it. If you have any questions, you feel free to drop them in the comment section of this video. I'll try to answer them when I have the chance. And thank you for watching. So this is my first video. So if you'd like to see more of this, not just the Flowgorithm, any programming like tutorials, practicals, if you are struggling to set up your VS Code or any IDE for that matter, if you guys are interested in these types of videos, then you can subscribe. If I get about 40 or 30 subscribers, then that would encourage me to start doing regular videos around this subject. So thank you for watching, and those who know me personally on campus, you can reach out if you have any challenges. Yeah, that's the advantages of networking. But if you don't know me too, you can just drop your inquiries in the chat comment section, and I'll do well to respond. I also talk to some of my colleagues, and they can come into the comment section and assist you guys. So thank you once again. Have a great day.